In this section, we're going to be talking about annuities. And so an annuity, kind of the key to be looking for this is you're going to be making a monthly deposit or a monthly payment, whereas the other ones we talked about, the compounding continuously, the compounding simple interest, that's really a one-time deposit and then you earn interest on that one deposit. You can identify an annuity by having to make a monthly payment or a monthly deposit. So think about it as a retirement savings account. If you're building your retirement, you typically have money garnished from your check to go directly into your retirement account, and that happens every single month. And so you're making this monthly payment. And so that's what you're looking for to identify using this annuities formula. So here are two formulas. So notice I have an or between them. So this first formula that I'm kind of highlighting in red, this is the formula that you will use if you're trying to find A, which is the balance in the account after a certain number of years. So if you want to find A, you will use this formula. By manipulating this formula and getting the D by itself, you can get this formula. So rather than having to figure out how to solve the equation and get the D by itself, I'm just giving you the two formulas really, okay? This is hopefully going to make it easier on you. So if you're trying to find the regular deposit that you're going to need to make in order to save a certain amount, you would use the blue or the second formula. So A is the balance in the account after a certain number of years. D is the regular deposit that you're going to be making. R is the interest rate in decimal form. N is the number of compounding periods in 1 year. And T is the number of years. So it's important to note that sometimes in these word problems or application problems, they don't tell you directly the number of times it's compounded in a year. And so if they don't tell you that, you assume that it's the same number of deposits that you make in a year. So in other words, if you make, or let's just say it matches, so N will match the number of deposits made in 1 year. So if you're making monthly deposits, you would assume that it's also compounding monthly. So the N would be 12. If you're only making semi-annual deposits, so you're only depositing something 2 times a year, you would assume that N is 2. So let's look at these and see how we can figure these out. Let's try one. So these formulas are much more complicated than the formulas we've looked at prior to this section. But we're going to figure out how to plug everything in, and then it's just a matter of putting it in your calculator and solving. So you deposit $150 per month, so that's D. So we can kind of label these as we go if we'd like. This is D. Into an account earning 7% interest, compounded monthly. Okay, so R is going to be 0.07 as a decimal. Compounded monthly means N is going to be 12. D is your monthly payment, so that's going to be $150. So we have D, R, and N. We need to get either A or T. How much will you have in the account after 25 years? So part A is giving us the T. So T is 25. Let me put that on the side actually. Okay, and so now that means we're going to be looking for A, how much you will have in the account after the 25 years. So let's use the first formula and plug everything in. So we're going to have A equals a big fraction, D, in this case it's 150. Okay, 1 plus R is 0.07 divided by N, which is 12, to the N times T, so 12 times 25 minus 1. And that is your numerator, and your denominator is R over N. So R over N. Okay, so when you're using a calculator, if you have a calculator where you can just put all of this in at once, make sure you add parentheses around your entire numerator. So I'm putting those in blue. And make sure you put parentheses around your entire denominator. Sometimes if you don't include those parentheses, your calculator won't give you what you really are looking for. So that's kind of a key here. So let's plug this in and see what we get. So when I put this in the calculator, I ended up with $121,510.75. Okay, so now let's look at Part B and Part C. So Part B is how much money did you contribute to the account? So keep in mind that the amount that we just got in Part A is how much you have in the account at the end. That includes all of your monthly deposits and the interest that you earned. So to find out how much money you contributed, keep in mind that you contributed $150 per month. And you did that for 25 years. So you multiply the amount per month times the number of months times the number of years. So $150 for 12 months gives you $1,800 per year times the 25 years gives you $45,000. So you contributed $45,000 into the account. To find the Part C, the amount of interest that you earned, you would simply subtract Part A minus Part B. So 121,510.75 minus 45,000. And you would get $76,510.75. So that's the amount of interest that you earned. And again, that was Part A minus Part B. Okay, so now let's look at the second example. And the graphic at the top with the two formulas and all the information about those formulas, I got that from the Math and Society textbook. It's a free online resource, and so you can see that I've cited that at the bottom. All right, so number 2, suppose your goal is to retire with $1 million in a retirement account in 35 years. You find an account that will pay you 6.5% interest compounded quarterly. How much would you need to deposit in the account each month to achieve your goal? So hopefully you can see that this one is different. This one we are given the A, but we want to know the D. We want to know how much you have to deposit every month. And so we're going to write that formula down and then use that formula to figure out our monthly payment. So let's scroll back up and see. So the formula for that is D equals A times R over N over 1 plus R over N to the NT minus 1. Okay, so there's our formula. So now let's plug in everything that we know. So the A is the $1 million. That's how much we hope, right? Maybe that's just a dream, but we can hope. Let's just see if it's realistic. So 0.065 is our interest rate, which would be a good interest rate to get these days. The N is compounded quarterly. So it does tell us it's compounded quarterly, so 4 times per year. And all of that is over 1 plus R over N to the NT. I have 35 years, so that's T minus 1. All right, let's see what we get when we put that in the calculator. So according to my calculations, it would be $1,900.22. So you would have to be able to deposit $1,900 every single month in order to achieve your $1 million goal in 35 years. So part B, how much would you be contributing in total? So we would find that by finding out the amount we would deposit each month. So $1,900.22 times 12 months in a year, and then multiply that by the 35 years. So $1,900.22 times 12 is $22,802.64. That's how much per year. And then 35 years of that, we would be depositing $798,092.40. So that's how much we're contributing to the $1 million. Now, what's kind of making this a low or a high amount of your contribution and kind of a low amount of interest earned is the number of times it's compounded. It's only compounded quarterly. If this compounded monthly, you would see a big difference. To find out how much money you would end up earning in interest, that's part C, you would subtract your goal amount, which was the $1 million, by the amount that you had contributed. So you contributed $798,092.4. And when you find the difference, that will be the amount of interest that you will have earned. So let's see what we get. I got $201,907.60. So that's how much interest you will have earned.